Let us take another example for machine learning with quantum computers. Simple examples, but let us try to do how the uh, machine learning problems can be tackled with the quantum approach. So in this example, two labeled points are given. The training data is as follows: x1, the first data is x1. Okay, let me just, the first data is x1 and its label is given to be, that means the target value is +1, such that y of x1 comma theta is +1, and the second data point is given to be x2 equal to pi. Its label is the target value is -1, such that the predicted value by the model should be -1. Now we have to use the quantum computer to train the model. So let us try to look into the solution of this example. Now the following are the conditions under which the model needs to be trained. So because we have to train the model, so we have two data points. One is with the x1 equal to 0, x2 equal to pi. So the first data point is we have to if we use the previous results in which y x1 comma theta should be was cos of x plus theta. So since it is x1, x1 we have for the first point is 0. This is 0 here, and theta value we can choose any value out of the whole range. So y of x1 comma theta comes out to be cos theta. So we want cos theta equal to +1. That's our target value. Now the second point is x2 comma theta, in which x2 is pi. So therefore using the previous example that was covered in the previous video, the output predicted value should be cos of x plus theta, which means cos of pi plus theta. In this case, cos of pi plus theta should be equal to -1. So we need to solve for these two equations, right? Cos of theta should be +1 and cos of pi plus theta should be -1. So cos of theta should be equal to 1. What theta value should be considered? Any value with defined by 2k pi for integer k, and for cos pi plus theta which is equal to minus cos of theta and is -1. So if cos theta is equal to +1, because it is cos theta, it is minus cos pi plus theta is minus cos theta. So if cos theta is 1, this cos of pi plus theta can be -1. So in both the cases, the theta values should be 2k pi. Therefore, any theta equal to 2 pi k will satisfy both conditions simultaneously. Now let us choose a theta value. For example, theta is 0. That is our we will choose this theta value as a parameterized value for our training purpose. For x1 equal to 0, this is our first data point and we have chosen theta value to be 0. So it comes out to be 1. So probability, if we calculate the probability, is with 1 plus, using the previous using the same previous formula, 1 plus cos function divided by 2, and this probability of 1 is 1 minus cos of gamma. Gamma was our x plus theta, which comes out to be 0. Probability of 0 comes out to be 1. Hence the measurement is always 0, which we can interpret as class +1, which matches with our target value which is +1. So if it is one class for data point x0, for data x1 equal to pi, it should get the other class, right? So for y x2 comma 0, cos pi is -1. So if we again you calculate the probabilities, we will get it 0 and 1. In this case, probability of 1 will be equal to 1. So therefore the measurement is always 1, which we can interpret as class -1, matches with the second target. So one single parameter, this is only for training of the training, this is the training done with single parameter, and this single parameter, which is theta equal to 0, lets this tiny quantum model perfectly separate the two training points, which means x equal to 0 for class +1 and x equal to pi for class -1. Now for completeness, we can also calculate, you can also find out the states. In the first case, the state will come out to be ket 0, right? So therefore, measuring in z basis gives me probability of 0 to be 1 and probability of 1 to be 0. And in the other case, we will get the state as ket 1, right? So, and the expectation values are also x1, for x1 expectation value is +1, for x2 the expectation value is -1. So these perfectly match with the labels. So using the procedure that we studied in the previous video, you will have to see the previous video to understand this question, but this question is chosen to for 2 data points. Otherwise exactly the procedure remains the same. Thank you.